Okay, so in the previous video, we had discussed how to find an approximation of the area underneath this curve, and we went ahead and talked about how we could kind of split this area up into four equal width rectangles. And then what we did was we calculated the area of each rectangle, and we didn't finish the problem here. And I also want to talk about a few other things about this approximation here. So first is first, let's go ahead and finish off this problem. If I sum up, so we said that the area of rectangle 1 plus the area of R2 plus the area of R3 plus the area of R4 will give us an approximation of the area under the curve. And so if we think about what we have here, we evaluated the function. So y of 1, what we did was, again, we took our 1 and we substituted it back into our function here. So 1 squared plus 2 gives us 3, so that's where the 3 comes from. And we did that for every single term that we have here. We plugged every single term here into our function, and it spit out some y value for our height. Now, if we add up this, 3 times 1 is 3, plus 6 is 9, plus 11 plus 18, we get an approximation of, so this is equal to 38. Now this 38, so we can say, and I'll come back up here, so we could say that 38 is and I want to put a little blank here because we're going to fill in this blank, is a blank approximation of the area under this curve, And I want you to think about what we have here, and I want you to answer this question. Is 38 an over or an under approximation? So looking at the pictures, it looks like every single rectangle falls short of the actual curve. And you notice we notice these little gaps here. We notice that we have, this gap that we're not accounting for. So there's still some missing area there. So we could say that this is actually an under approximation of the area of this curve. Now the next question would be, well, how do I construct an over approximation of the area underneath this curve? And well, if you think about the way we constructed these rectangles, if you notice the rectangle, the left side of each rectangle is touching the curve. So the left side of this rectangle is touching the curve. Well, what if I decided to, I don't know, draw a rectangle such that the right side of the rectangle now would touch the curve? So my new rectangle might look something like this here. And if I drew this rectangle here, you could clearly see that now my rectangle goes above the curve, which means that I would now have an over approximation. So again, my right rectangle here would be an over approximation. That's very interesting. So then what we're saying is that let's say I draw another right rectangle here, and let me actually do a different color than blue. Let's see, let me do bright green here. So let's say I drew another rectangle in green. Excuse all the mess here that I have, but I hope that you can kind of see what I'm doing here. Then notice that this white line again is underneath. We're including some extra area right here. So again, this would be another over approximation, and we could keep doing this. I could keep drawing rectangles here. So I could draw another right rectangle to get another over approximation. So there we go. And then finally I could draw maybe my last one here, here. So here would be my last over approximation. So now I could definitely say that, my over approximation of the area underneath the curve would definitely be greater than 38. Now the next question I could ask you, well, what if you average those two? So a lot of students might think, well, hey, I have an under approximation. Let me go ahead and find the over approximation. I can add those two approximations up, divide by 2, calculate the average, and boom, I should have the exact area under the curve. Well, that's not always, that's not quite true. You could definitely find the over, you could definitely find the under, and you can definitely find the average between the over and the under. But that will not give you the exact area under the curve. That will give you something else, which we will discuss in another video. But these are two examples of the rectangles that I can draw. The first example that we saw here that we calculated, this 38, is called a left sum. So I'm going to go ahead and write that here. The 38, the under here in this case, was called a left, and we're going to say left of 4 because we had 4 rectangles. If I were to do an over approximation, so if I were to do an over approximation, then what I would have to do is calculate a right sum, and I would have a right of 4. So the question we will finish this video off with, we're going to ask this question here. Is a left approximation always, or I'm sorry, is a left sum always an under approximation? And is a right sum always an over approximation? Well, not always. I'm going to sketch 2 photos here, so let me go ahead and just create some more space here. All right, there we go. Okay, so look at these two pictures here. So here we have some y axis, and then here we have, let's say, some x-axis there, and I'm just going to sketch the photo that we had before, which is something like this. And we've already seen that if we do a left sum, in other words, where every single rectangle that we sketch, the left side of that rectangle would be touching the curve, we saw that these would give us some type of under approximation. Okay, and similarly, if I did a right sum, so let's say I just decided to do these over here, where every single triangle touches the curve on its right side, so here's another one, then I would have an over approximation. So my right sum would be an over approximation. Well, what if I sketch this curve now? So what if I have, let's try to make this as straight as possible. Let's see. It's y, and here's my x-axis. Okay. Instead of having an increasing function, what if I had some type of concave up decreasing function like this one? And now let's look at the left. So would my left sum be an over or an under approximation? Well, let me just draw any rectangle with the left side touching the curve. So there's my rectangle. Well, not necessarily, not yet, right? There's my rectangle. And so now look at that. My left rectangle now is would be considered an over approximation. Versus now if I were to draw a right triangle, so if I do, I'm sorry, I said triangle, I meant rectangle. My rectangle now, if the right side touches, would definitely be an under approximation. Well, that's interesting because, again, not always will the left be an under and not always will the right be an over. In some cases, it just depends on our curve.